Go, we're talking about all the stuff you need to know before this big test we have on Friday, the algebra review. And we're going to cover all of these things. I already read them to my class, so I'm going to just kind of skip over that for now. You can always read it at home if you'd like to. Solving by graphing, that's where you graph two lines and you see where they cross. If you're going to graph two lines and see where they cross, and you've got a graphing calculator, you can use the little trace function and say, where is that spot? And it'll tell you. I'll tell you. This is at 6, 2. That means that, is it 5 or 6? Let me make sure. Yeah, it's 6. 6, 2. That means the solution to this system is 6, 2. There's two answers, the x and the y. All right, graphing's super easy. Just graph both parts and see where they cross. I'll talk to you more about that as the year goes on, because this is a super powerful way of solving equations you could have been using all the way back to middle school. You can graph two equations and see where they cross for this too. You graph this side, you graph this side on your y equals screen of your calculator, and you see where they cross, and that's the answer. Don't have to solve it. Don't have to like add 6 to both sides, and you know. You just graph them, see where they cross. Yes, sir. You're right. Going too fast. I'm sorry. Thanks for catching that. It's 2, 6, not 6, 2. Sorry. Okay. So my point here is that you can solve systems by graphing. You graph both sides and see where they cross. All right. Moving on. There is these two equations. I would like you to graph them, sketch them on your paper. Just make a little quick sketch. This does not have to be perfect on graph paper. Graph both equations and see where they cross. All right. In case you forgot how to graph y equals 2, pick one spot where y is 2. That's a spot. And then you got to figure out, is it a straight line vertically or horizontally? I think you'll quickly figure out this way wouldn't make any sense. You're going to touch a whole bunch of other y's. This way, you keep touching only where y is 2. That's one of your lines. The other line, you start at -4, and you have a slope of 2. Up 2 over 1, up 2 over 1, up 2 over 1. And look, the lines just cross. That's the spot. And I know on your sketch it might have been hard to see exactly where, but how many of you had them generally crossing about there? Okay, good. And it's 3, 2. Not like I was before, a little dyslexic, had it backwards, but over 3, up 2. All right, so there's my answer. X equals 3 and y equals 2. Well, I already knew y equals 2 because it says so right there. And couldn't I have just substituted this into this equation and stuck this in here? Put the y equals 2 in there and then solved that? Yes, I could have. That's called substitution. So if I stick that 2 in there, and I'd have 2 equals 2x plus 4, or subtract 4, sorry. I would add 4 to both sides. I'd have 6 equals 2x, so x has to equal 3. That's another way I could have solved it without ever graphing it. That's called substitution. That's what's next. Because sometimes they're ugly to graph, like these two would be ugly to graph. But you can solve by substitution. You just take this, y equals 5 plus x, and I say, well, if y is 5 plus x, I can put that right here. Y is 5 plus x. I put a 5 plus x right there. And then I solve it. I'd like you to write that equation right there, 3x minus 2, parentheses 5 plus x, equals 12, and solve it. Then you'll know what x is. And then try not to forget that there's actually two answers. Once you found x, and let's say x comes out to like 4, you just plug it back in and you can find the y really easy. 3x minus 2x is just x. Minus 10 equals 12, and then I add 10 to both sides. X equals 22. Once I know that x is 22, raise your hand if you got that. Okay, good. Then I take x is 22 and I stick it into either equation I want. I prefer the easier one, so I stick in the 22 right there. And then what does y have to be? 27. 5 plus 22. So y is 27, x is 22. Could I write that as 22 comma 27? That'd be really smart. Don't have to. You can write it out as x equals 22, y equals 27. But this is a little more efficient. Any questions on solving by substituting one equation in the other equation? All right, if I was going to give you one more that had a little bit of a twist on it, it would be, how am I supposed to do this? I'm not even going to do elimination. I'm going to do substitution again. If I'm going to do substitution and sub the one into the other, this isn't solved for anything. I can't like say, oh, x is this, unless I what? I could solve it for either x or y. And I can either say x equals, and then bring this y over here, and say 2 minus y. Or I can solve it for y. If I were to solve this thing for y and get the x over there, I go minus x, and I'd have y is equal to negative x plus 2. Personally, I like that one better, just because it is less messy, because that negative x is kind of icky. So now that I've done that, would you please substitute this into this and see if you can get the right answer. I have a big parentheses because I'm going to drop in something big. 2 minus y plus 6y equals 30. And I've only got y's in my equation now. So, should be fairly easy. Negative 6 plus 3y plus 6y equals 30. Negative 6 plus 9y equals 30. Add negative 6 to, or sorry, add 6 to both sides. And I have 9y equals 36, and then 9 times what makes 36? Y must be 4. Raise your hand if you had that one right. How many of you went on and figured out what x was? Only about 7 of you. That's what you're supposed to do. Once you get y is 4, you got to go back and figure out, well, what's x then? If y is 4, you're getting that x would have to be something that would actually make 4 smaller, because it has to equal 2. So anyway, I solved this little equation. X plus 4 equals 2. Subtract 4, x has to equal negative 2. All right, so if x is negative 2 and y is 4, this would be an okay answer, or negative 2 comma 4 would be an okay answer. That is called solving systems of equations on your test tomorrow. Something you learned before. It's been a while though, I know. Last year was geometry, so you probably forgot a lot of this stuff. All right, multiplying binomials out. FOIL. Remember that first outside, inside, last? Does that ring a bell? Okay, I'm going to multiply this by this. That's my first. 2x times x makes 2x squared. Outside. Outside is this. Those are the two outside terms. 2x and negative 5. What's 2x times negative 5? Remember, this is a multiply problem. 2x times negative 5 is negative 10. These were the outside terms. Next comes inside, and last is last. The inside ones are this and this. 3x, or 3 times the x makes 3x. And that's positive, because they were both positive. And then the lasts I'll do with green triangles. Those are the lasts. They're the last of each binomial. 3 times negative 5 makes negative 15. I hope that this is something that you remember for... Oh, I made a little mistake. Somebody should have stopped me. Yes, thank you. Please, don't be shy about catching me on that stuff. All right, and the last thing is to put it all together, and that's 2x squared that and that go together and make minus 7x. And the last one is that, minus 15. There it is. Do you think you could have done that? How many of you feel comfortable with FOIL? You're like, I'm good at that. Okay. All right. This one is also a FOIL question, and yet a lot of people try to go, I'm just going to take that squared, and then I'm going to take 3 squared and make it 9, and that's my answer. Wrong. It's a really common mistake, because they think, well, I'm just going to square both things. There's an adding in here that makes it all different. So what you got to do is think, what does squared really mean? Squared really means times yourself. So 2x plus 3 times itself. Now, do you get how it's actually a FOIL question? First outside, inside, last? Go ahead, FOIL it out. You'll have a 4x squared in it. You'll have a 9 in it. But there's another term that people that tried it the other way wouldn't have gotten. So do first, outside, inside, last on this. And we'll pause while you're working on that one and get attendance done or something. Okay, so you should have said firsts, that and that, 4x squared. It's a really easy mistake to say 2x squared. It's 4x squared. Outsides and insides are those two. The outside one is 2x and the 3 makes 6x. The inside one's also 6x. That makes a total of 12x. And my last is 3 times 3 is 9, plus 9. So you can see the people that would have just squared the first and last term, like take this squared, they would have got this. And that squared, they would have got that, but they wouldn't have had the middle term. Really common SAT, ACT kind of question to catch people who are just trying to do it in their head quick. You gotta write it. Squared means times yourself. Okay, moving on. Factoring. You gotta be good at factoring. That's something that you learn the basics of. You're gonna get really good at it this year. And then we do like hardcore, serious factoring. So this is the easy stuff. See if you can factor these 3. They go something like this. Quick reminder, you always start with, if this is x squared, you go x and x will make the x squared. And you just got to figure out what number to put here and here to make it factor. So like, I'm not going to write the right one here, but let's say it was 8 and 2. Your answer would be something like that. See if you can factor this one without me first. All right, I hope you knew that the only way to make a 10 is with a 5 and a 2, because you have to multiply this number and this number together to get 10. 5 and a 2, or you could have done a 10 and a 1, but the 5 and a 2 also has a difference of 3, and that's what I'm looking for here. So I knew it was a 5 and a 2. Now the hard part is figuring out what sign to put on what. And if you notice that the middle term you're supposed to come out with is positive, then you know the bigger of these two, if I'm going to make one of them positive, I should make the bigger one positive. And the other one can be negative. And there we go. Raise your hand if you had that one right. Okay, good. This one is harder to factor. Has anybody already got it factored? Awesome. Now, before you say the answer, if you're going to factor this thing, remember, if you think the answer is x plus 5 and x plus 5, you can check it. Remember, you can check by multiplying it out and seeing if it works. X times x, x squared. Outside and inside makes a total of 10x. Do you see a 10x in here? No, so that isn't right. What did you think the answer was? Yep. Ah. How can I know he's right? Check it. By doing what? Just multiply. X times x, x squared. Outside and inside, there's the magic. They're opposites, so they will cancel, so there is no middle term. And then the lasts, remember it's first, outside, inside, last. The lasts are this, and they make negative 25. It worked. Nice job. Okay. This one here adds one extra little step. You can do it the long way, which is to start off with parentheses right away, but there's a way faster way. If you noticed something, does anybody notice it? There's a 3 in all of them. Yes. They're all times by 3. How do I get that 3 out of all of them? I factor it out. So what that means is they all have a 3 in them. So I'm going to take a 3 out. What do I have left? X squared plus 3x plus 2. And again, with factoring, the beautiful part is you can always know if you're right. You just multiply it back out. 3 times the x, 3x squared. 3 times the 3x, 9x. 3 times the 2, 6. It worked. But it can be factored again. So get the 3 out. It's a good step. That's called the GCF. Once that's out, I can factor it again with this way. X and x, and then has to multiply to this and add to this. What multiplies to 2 and adds to 3? 2 and a 1. And they're all pluses here, so there we go. That's factored completely. You probably didn't factor too many like that. Maybe you did some. But we do a lot like that. It's harder core factoring. It makes sense. You're in Algebra 2. That's Algebra 1 for regular factoring. And this isn't hard factoring. We're going to get the really hard factoring, where this is like x to the 4th, or even x to the 5th. And you'll learn how to factor those. But for right now, we're just brushing up, seeing how good you are at your basics. All right. The last general topic here is data. Do you remember mean, median, mode? All right, mean is the middle one. No, it's not. What is it? Average. Mean's the average. How about the median? Middle. The mode? The one that happens the most. Most common is a good way to say it. And the range? You take the biggest minus the smallest. So like from 3 to 11, but you actually do subtract them. The range on this is then 8. Because 8 is what 11 minus 3 gives you. All right. The min is easy. That's the smallest number. The max is easy. That's the biggest number. The median, by the way, is not just the middle one on any group. I can't just grab the middle one. I got to line them up from smallest to biggest first. All right. So I'd like you to write these numbers in order from smallest to biggest. Keep in mind that there are 1, 2, 3, 4, 5, 6, 7 of them. Make sure you got all 7. Line them up from smallest to biggest. Then pick out the middle one for me and circle it. Then I'm going to show you how to find Q1 and Q3. I bet you nobody in here remembers Q1 and Q3. Does anybody? You do? Sweet. Couple, 3 people. Nice. All right, so you go like this. 3, 3, 4, 5, 7, 8, 11. All right, so would you agree, 1, 2, 3, 4, 5, 6, 7, I got all 7 numbers, that's the middle number, right? Okay, now, that's called the median, middle one. Now what you do to find Q1 is you take the middle of this group. That's Q1. And now what you do to find Q2 is you find the middle of that group. Sorry, 3. Q2 is this one, actually, technically. And what does Q stand for? Quartiles. I mean, quart means like 4, you know that? Quartile, 4. There's 4 quarts in a gallon. Anyway, so these are quartiles. What they're doing is dividing your data up. Let me use big black lines here. That's the middle of your data, right? This is the middle of the lower part of your data. This is the middle of the upper part of your data. You see how I just divided it up into 4 parts? Divides my data up into 4s. So you can tell if you were in the top 25%. So let's say these were amounts in millions of dollars that people had made. And $11 million was the most anybody had made. 5 million of this group of really rich people, 5 million was the middle of the group. So if somebody had made, let's say, the 7 million, they knew they were not in the top quartile, not in the top 25%. The top 25% is this group right here. And 7's below that. So they were between 50% and 75%. That's all we could know for sure. Because 50% is right here. And 75 percentiles right here. And this is 25th percentiles right there. Okay, and most of you guys, when you tested on your math, I know you probably ended up in the top 10% at least. I'm sure there's lots of 99s, 98s in here. Probably some of you in the 80s or whatever, but this is kind of what they do to figure that out. It also has to do with box plots or box and whisker plots. We're not going to actually make you make a box and whisker plot, but all right. Last thing I want to talk about is, say I'm selling ice cream at the park. I got a little stand and there's some fixed expenses each day that I can't avoid, even if I don't sell any ice cream. So in other words, say I have an employee and I got to pay him $100 to stand there all day. I mean, that's a fixed expense. Even though I don't sell any ice cream, I got to pay this guy. All right. In this case, I'm the only one working the stand, so it's pretty cheap expenses. But why might you have $30 in expenses? Well, one thing, the park doesn't just let you have your stand there for free. A lot of times they charge you to have your stand there. It's like rent. The most expensive rent in the United States, I believe, is actually at the Mega Mall. Our Mega Mall has incredibly expensive rent because they do such business. They do so many millions of dollars worth of business. I mean, if you just have like a Chipotle in the Mega Mall compared to a Chipotle in a regular mall around here, gonna be way, like probably 3 times as much business there. So they make 3 times as much money. So they charge them a lot more for rent. Okay. Anyway, so in my park, my fixed expenses are $30. Also figure that when I do sell a bowl of ice cream, the ice cream itself costs me about $1 because it's not free to get the ice cream. So my fixed expenses is, no matter if I sell any, I got $30 in expenses. And then for that day, I also have $1 every time somebody buys one. That's expense. I don't even have how much I sell the ice cream for. Let's say it's $4 or something. You could figure out profit on it later if you wanted to. But for right now, all I'm talking about is the costs. So I could say C for cost is equal to, what do you think? 30 plus, say it if you know it.
1.
Yep, 1 and then C for cone or whatever, any letter you want. You got a good point. Unless one's a lowercase and an uppercase, but okay, let's just use X. X is how many cones I sell that day. So if I sell 10 cones that day, it's going to be $10 for the ice cream plus the $30 for standing there. But if I'm selling them for $4 each, I could figure out my profit on that. The profit would be how much I sell them for, which is $4 for each cone, minus all my costs, which are $30 plus $1 for each cone I sold. So that's my profit function. So if I know that I sell, let's say, 10 cones, am I even going to make any money? Probably not. Maybe make it like 20 so I can actually make a profit. So 20 cones here. Then my expenses were 30 plus 20 times 1 is 20. Makes $50 of expenses. And I had $80 of income. 80 minus my expenses makes, I could make $30. Okay. Much more complicated when it's like Apple Computer. But in the end, it's their profit. It's how much they made minus their costs. They have costs. Got to pay all these employees. Got to pay people to make stuff. Got to buy the actual computer components. Apple's probably got the highest profit margin of any company in the world. All right, last thing. I have had 2 tests so far, and I got a 98 and an 85. I don't know what I'm going to get on my 3rd test. What do I need to get in order to average a 92? Okay. How do you do something like this? Well, it's really an average, right? To do an average, don't you just add up a bunch of things and then divide by how many there are? All right. What are the things I'm going to add up? I'm going to add up my 98 with my 85 with my I don't know what. So what shall I put? N or X. I'm going to put N. I added up all my scores, and then I'm going to divide by what? 3. What's the one number I haven't used yet? 92. You can't just always do that because, you know, they might be throwing in a number you don't even need. But I do need that 92. An average, they tells me the average. The average is going to come out to 92. There's how you solve, or there's how you set up that equation. All I'd have to do to solve it is times by 3. And that gets rid of this because divide by 3 and times 3 would cancel each other out. And then I just have to add these together, subtract, and I'll have min. Okay? All right. I'd like you to try this situation. Imagine that you have, so far, out of 5 points, you got a 4 out of 5 on your first assignment, and a 3.5 out of 5 on your second assignment. What do you need on your third assignment to average a 4.5? Keep in mind, I do give extra credit sometimes. So what do you need to get a 4.5 average? Write it out. If you just watch me do them, it doesn't work nearly as well as you trying them. Okay, hopefully you said 4 plus 3.5 plus, I don't know what on my last one. I'll average it means divide by 3, and then I need it to equal, what did I say it was supposed to equal? 4.5. That's how you set it up. And next thing you do is times both sides by what? 3. If it times by 3, 4.5 times 3. And this times 3 is going to cancel the divide 3. And now I have 4 plus 3.5 is 7.5 n, or plus n. 12, 13.5. And then I just have to subtract 7.5 from both sides. And I have n equals 13 minus 7, which is 6. I need a 6 out of 5. I do actually offer extra credit sometimes, so that's possible. If you got a 6 out of 5, and you could average a 4.5. Okay. Covered everything that you have to know. If you understood everything I taught you right there, you're going to do fine on the test tomorrow. And the homework is right here. And I can stop my recording.